Hello and welcome. We are here at Cape Canaveral Air Force Station in Florida, getting ready for the launch of NASA's Ionospheric Connection Explorer. That is ICON for short. I am Karen Fox, and we are going to be talking today about this plane right behind me. That's an L-1011. It is going to help launch ICON up into space. We're going to go inside, we're going to walk around. But before that, we are talking to Scott England. He is the project scientist for ICON from Virginia Tech at Blacksburg, Virginia. Welcome.
Welcome. Hey.
Start out just telling us about the Ionospheric Connection Explorer. What is that? What is the ionosphere?
So the ionosphere is the very top of Earth's atmosphere. It's this region where our atmosphere reaches space. It's the first region that sunlight hits when it reaches our atmosphere. And at these altitudes, the sunlight is able to actually break apart the atoms and molecules that make up our atmosphere, and it can energize them and ionize them, forming charged particles. And we call these charged particles the ionosphere. And because they're charged, they can interact with spacecraft and also radio signals, such as GPS, that try and pass through this region. So we really want to understand these charged particles and their behavior. Another phenomena that we get in this region is that as the sunlight energizes and ionizes the particles, they're actually able to emit light. We call this air glow, and this is a really fascinating phenomena of this region. There's an example of air glow that people may have seen called aurora, which we get near the North and South Pole, and that's a very bright form of air glow, but there's actually air glow all over the planet, even above us right now.
Is it something we can see up there right now?
So if we went above the atmosphere, like astronauts at the space station, and they look outside of the space station at night, they see this beautiful green glow right around 60 miles above the surface, just on the very edge of space.
All right, so you've explained about the ionosphere and how there's a lot going on there, and we've got to know about it to protect our communications in space. And I think astronauts are up there too, right? We're looking out for them.
Absolutely.
Tell us a little more about what ICON's bringing to the table. What kinds of observations will it be able to help with?
So this region around 60 miles above the surface is really inaccessible. It's much too high to fly an airplane like this and get measurements. It's also too low to fly a spacecraft directly through this region. But it's also the region where we think that the real connection between our atmosphere and the ionosphere is taking place. So ICON is going to make use of this air glow. So ICON will be flying in low Earth orbit around the top of the ionosphere, making measurements from its altitude and just down into this really inaccessible region, taking images and spectra of this air glow and really seeing how is the air moving, what's the wind speed, what's the temperature, and then where are these charged particles being formed and how are they moving, and really show us this connection between the neutral part of the atmosphere that we live in and these ions at the edge of space.
So you're describing this area, it's changing all the time, there's a lot going on there. What is making it change? What's driving all of that?
So we know that the ionosphere is formed when sunlight hits the atmosphere and breaks apart these atoms and molecules. So we know that the sun plays a really important role in transforming the ionosphere. But over the last 10 years or so, we've had these observations of the ionosphere from NASA missions and of the sun, and we can really say that it's not just changes in the sun that are driving what we see in the ionosphere. And through piecing together these observations of the ionosphere and bringing together observations actually of the atmosphere at much lower altitudes down near the surface here, we can see reflections of patterns that we see, especially in large-scale weather systems like tropical thunderstorms, and how they change over time. We then see an imprint of that on where these charged particles are in the ionosphere. And what we think is happening is not that these tropical weather patterns are reaching all the way up to the ionosphere directly, but we think that their information is being communicated there through atmospheric waves. So much as this airplane behind us, if you see it up in the sky, you can hear its engines. Now what's happening is not that the air from its engines is coming down to your ears, but sound waves are traveling through the atmosphere from the engines, bringing that energy and that information to you. And we think the same sort of thing is happening at very large scales between these large-scale, lower atmosphere weather systems communicating energy and information up to the ionosphere through atmospheric waves. And ICON's really going to get us observations of these by measuring how the atmosphere is moving and then how the ionosphere is really responding and how this connection takes place.
Well, thank you so much. We're looking forward to learning more about how the terrestrial weather and the space weather are connected with ICON. Thanks for being here today.
Thank you.
All right, we are now going to go over to the plane and learn a little bit more. We're going to go talk to Ed Dunlap with Northrop Grumman. Come on along. We are talking to Ed Dunlap with Northrop Grumman. He manages the plane operations for this launch. You still have behind us the airplane. And obviously, this is not a standard launch the way people think of a rocket going up into space. So tell me a little bit about this plane and how it's going to get ICON up into space.
Okay. Well, first of all, this is the Lockheed L-1011 TriStar. TriStar meaning it has 3 engines. It was originally designed to carry 300 to 400 passengers, but my company purchased it and modified it completely structurally so that it can mount this 52,000-pound rocket to the belly of the airplane. What we will do on day of launch is we will take off, we will fly up to 39,000 feet, which is our drop altitude, and then the airplane is essentially the first stage. So it's a reusable first stage. We can bring it back and use it again and again. This will in fact be our 38th launch off of the L-1011. And in that time period, because not every satellite is a single satellite, this will actually be the 91st satellite that we will launch off this aircraft.
Now, you said it was a passenger plane. Can you tell me a little bit more about the history of this plane?
Yes, it was actually built in 1974, and for 15 years it served Air Canada and hauled thousands of people all over North America, even spent some time in India, flying around in India, until we purchased it and have been using it ever since.
And inside, when we go in there, is it going to still have seats? What does it look like in there?
Well, actually, because of the modifications, this airplane's sole purpose is to get up to altitude and drop that rocket. So all of the passenger accommodations, except one lavatory, thankfully. I'm very glad they did that. They left the lavatory in, but everything else was taken out to lighten the load so that they can get to altitude very quickly. There are about a dozen passenger seats that you'll see in the cabin, and that's because we do, like when we came here from California, we did a captive carry flight, and we have extra aircraft crew members, rocket technicians, and engineers that accompany us. There's always the possibility that we might have to off-land, and we have to have everything on board the airplane that we may need for any contingency that may happen.
All right, so you've told us a lot about the plane. Tell us about that rocket. How does it launch into space?
Yeah, this is a great rocket. It's a 3-stage solid booster rocket. You can see the first stage, the separation point, just in front of the wings. That stage gets it to about 180,000 feet. There's a second stage that you can see, that metal ring. That gets it actually out of Earth's orbit, and then the third stage gets it into its proper orbit. The satellite's in the very front of it, and once it gets in this particular case, it's going up to 360 miles in space.
Well, thank you so much. We're going to go inside now to check out that plane. I enjoyed talking to you. Thanks
Excellent.
a lot.
Nice talking with you.
So now here we are about to enter the L-1011 and talk to the crew that will be with the plane during the launch. We are talking now to Jim Stowers. He is the launch panel operator who will be in this plane when ICON launches. And here we are, I see a lot of launch panels.
Yep, this is the launch panel operator station. What we do here is monitor the telemetry, the status of the rocket, and the health of the satellite. We also provide power, do the functions that the launch conductor has us do on launch day.
And so here we are, we're on launch day. What are you actually doing during the launch?
It gets busy at times. We'll monitor the air conditioning system to make sure we're providing the right temperature into the fairing for the satellite. We'll be powering up the rocket, doing our systems checks as we go through the checklist, and just watching everything that goes on.
So you're watching to see if the spacecraft is healthy, if the rocket is healthy. What happens if you see something that's concerning?
If we see something, we'll get on the radio and tell the launch conductor and bring his attention to it, and he'll get his engineering team looking at it as well.
All right, and if everything goes perfectly, do you get to push the button to let it go out?
I get to arm the release mechanism. I don't get to push the big button.
All right, we're going to find out more about pushing the button soon. Thank you very much, Jim, for today.
Thank you.
Now we're going to go to the cockpit. All right, hello, Don.
Hey, Karen. Thanks for stopping by.
We are talking to Don Walter. He is a pilot who will be piloting the plane during the launch. And here we are in the cockpit. How cool is this?
This is the best job in the entire world, absolutely.
So walk us through what you're actually doing during the launch.
Well, a great part of the launch takes place on the ground before we take off. We do a lot of pre-flight planning. I brought actually a little bit of here for you to see. Most of our planning involves getting to the point where we're actually going to launch the rocket. The point where we're going to launch the rocket is over here. We need a little bit of space to climb up to our launch altitude. Just to give you a perspective, we're sitting right here in the skid strip. You can see a little blue flashing light here. The distance out to here is about 114 miles. So on a clear night, our spectators will be able to stay on the beach and actually see the launch, although we do launch off away from Florida. But again, the majority of what we do is planning, and then on launch day, we just execute the plan.
So I'm seeing this giant figure 8 here. Does that mean you can go around and around? How do you do that?
All right, so if you follow my finger along, what we do is we're going to depart out of here, and we've given ourselves about 160 miles because with the rocket attached to the outside, it takes quite a while to climb up to our launch altitude of 39,000 feet. So somewhere right around here, we get to our launch altitude and we come back through our launch point. Check the winds, check the weather, check the turbulence, and from that point, it's about, I'd say 30 minutes to come back around the pattern, back down to the launch point, and actually launch the rocket. You see there's sort of a horse racetrack type pattern here. Depending on weather and other factors, we have basically 2 attempts to launch the rocket. Generally, we try to launch on the first time, but we do have the ability we call a recycle to come back around and fly the pattern one more time and launch again. And afterwards, we just come straight back to where you're sitting right now.
All right, so I heard the button to launch the rocket is actually up here. Is that where it is?
It's up here, and we get the command from our launch coordinator down on the ground, and when everybody agrees we're in the right place at the right time at the right altitude, we're given the go-ahead to launch the rocket. And the button to launch the rocket actually sits right here. We have 2 pilots up here, so I'm flying the airplane, and my co-pilot, Steve, will actually be the one to push the button.
So walk me through that. Paint me a picture. Here you are. You launch the rocket. What happens?
All right. Well, so a little bit of his basic physics. When as soon as Steve pushes the button, there's a hydraulic release that opens and allows the rocket to leave the airplane. Well, the rocket weighs 52,000 pounds. So you can imagine if you lost 52,000 pounds all at once, the aircraft still has the same amount of lift. So the aircraft rises because we don't have the weight anymore, and the rocket falls for about 5 seconds. And it's that separation that gives us a pretty good safety margin from the time the rocket leaves the airplane till it actually lights off and motors out ahead of us. It's a fairly abrupt drop, so when the rocket releases, it's a fairly good shake, and it pushes us back in our seat quite a bit because the airplane is actually rising quite quickly. The rest of it is just, we have the best view of anybody at NASA or in our company of the launch. It's an absolutely amazing, spectacular view, and at night, you can imagine the fire that comes off the thrust of the rocket moving ahead of us and then climbing basically off into space. We can watch both stages, the first and second stage, on a clear night, which is quite it's an amazing experience, and we're really lucky to be in a seat like this. Call this our office.
And then, of course, after it launches, we are going to be waiting 1 month for that incredible research that Scott England told us about to understand how terrestrial weather and space weather interact. If you want to keep track of the mission, you can go to nasa.gov/icon and stay tuned for great things from this great mission and this great launch. Thank you so much. Bye.